Dear students, class 10, today we have taken a topic on mathematics on request. Our topic is root 2 is irrational if proof. Means we have to prove that root 2 is an irrational number. So let's discuss some fundamental concept of rational and irrational numbers. So rational number expressed in form of p by q or a by b are the case. But the condition here b is not equal to 0. If it is 0, then the result will be undefined. Okay? So rational expression is in form of a by b. Okay? So then what is the decimal expression of a rational number? So decimal expression, there are two categories. One is terminating, means the remainder becomes 0. And the second case, non-terminating, but after decimal, the digits are recurring. That is called non-terminating and recurring. These two categories come under rational number. But you see, irrational number expression. So, this is non-terminating and non-repeating or recurring. So, please remember, root of prime numbers are irrational. So, we have taken some examples. Root 2, root 3, root 5, root 7, root 11 like this. These are all irrational numbers. So, we have to prove today this root 2 is irrational. Okay. But here I find most of the students, they remember by practicing several times or by cramming, they remember the proof, and even after the exam is over, their content, the learned knowledge, the learned content is lost. So this is not mathematics. And dear students, please remember this proof, the proof root 2 is irrational, is exclusively based on a theorem called Fundamental Theorem of Arithmetic. Fundamental Theorem of Arithmetic, that is 1.3 theorem given in your textbook. So let's discuss what is Fundamental Theorem of Arithmetic. Let P is a prime number. If P is a prime number, if P divides A square, what is A? So A is a positive integer. And if P divides A square, it implies that P also divides A. A is a positive integer. That is the basic concept of the fundamental theorem of arithmetic. And basing on this concept, this theorem, the root 2 is irrational has been proved. Okay? So we have taken some example for your understanding and for your clarification. So examples, here P is a prime and A is a positive integer and that is A square. So we have taken two prime numbers 2 and 3. Now you see 2 multiple 1 and 2. So 2 square 4. So 2 divides 4 and 2 divides A 2. Now 2 multiples of 2, that is 4. 4 square, that is A square, 16. Now 2 divides 16 and 2 divides also 4. Now you see 2 multiple of 3, that is 6, and 6 square is 36. So A square 36. 2 divides 36 and 2 divides 6. Now we got the proof that when P divides A square, P also divides A. So let's discuss another example. That we have taken 3 is a prime number. You know 2 is the least even prime number and 3 is a prime number. Now you see 3 multiple of 3 multiple of 1, 3. 3 square 9. So 3 divides 9 and 3 divides 3. So 3 divides a square and 3 divides a. And 3 multiple 2, 6. 6 square 36. 3 divides 36 and 3 divides 6. And 3 multiple of 3, 9. So here a is 9 and a square is 81. 3 divides 81 and 3 divides 9. Now it is proof if p is a prime number and if p divides a square, p also divides a. Basing on this theorem, we have to prove that root 2 is irrational. So let's prove. Let's prove. First point, assumption. Let's assume root 2 is rational. So then expression, how can you write? So expression is root 2 is equal to a by b. So that is a form of a rational number. So here b is not equal to 0. That we have discussed. Then a and b are co-prime. So what's co-prime? That we have already discussed. Their highest common factor is 1. There is no factor other than 1. Okay? So come to the next point, squaring both the sides. So this is LH side and this is RHS. So squaring the both the sides, we get 2 is equal to a square by b square. By transposition, we get 2b square equal to a square. That is our equation number 1. And you see, so a square is a multiple of 2. Here 2 is multiplied. A square is a multiple of 2. It means 2 divides a square. And when 2 divides a square, that implies 2 also divides a as per fundamental theorem of arithmetic that we discussed here. Here, prime number p is 2. P2 means the prime number is 2. Suppose we are going to prove, suppose we prove root 3 is irrational. So you have to write here p is 3. So now what we got? So a is a multiple of 2. Now you see a is a multiple of 2 because 2 divides a. So let's take some example. So a 2 multiples of 1, 2. Here k is 1 and k is 1 means we can write a is equal to 2 into k. Because here what is k? K some integers. That has been explained here. So a 2 into 1, here k 1, 2. So 2 divide. So a divides 2. A is divisible by 2. And here a 2 into 2, 4. A is also divisible by 2. A 2, so 2 multiple 3 divisible by 2. So simply we can write a is 2 multiples of integers. So let it be denoted by symbol C in your textbook. It is given C. Here you are confused. Why C? So A 2 into C or K. So K is some integers. So 2 multiples of any integer, it is divisible. But A divides or A is divisible by 2. Okay. So we got A is equal to 2K. So squaring both the sides, what we get? A square is equal to 2K square. Implies A square is equal to 4K square. That is our equation number 2. Now, equation number 1. Put the value of A square in equation number 1. Okay. So let's write the equation number 1. That here equation number 1. So 2b square is equal to a square. So we can write 2b square is equal to 4k square. Why? Because we got here a square is equal to 4k square. Okay. So 2b square is equal to 4k square. By simplifying we get, or cancelling or simplifying, b square is equal to 2k square. Now we got the b square is a multiple of 2. Here 2 is multiplied. So b square is a multiple of 2. It means 2 divides b square. So when 2 divides b square, 2 also divides b as per fundamental theorem of arithmetic, that is A T A where p is 2. For prime number 2, 2 divides b. Now what we conclude? So our conclusion. So 2 is a common factor of both a and b. So a has a factor 2 because 2 divides a, and 2 is a factor of b, 2 divides b. So 2 is a common factor, at least a common factor of both a and b. But what did we assume? Our assumption was a and b are co-prime, means their common factor is only 1. The SCM, highest common factor, is 1. So it contradicts our assumption. So hence we can say, therefore, it can be stated that root 2 is not rational, but root 2 is irrational. Hence proved. But what tricks you have to remember? 2 tricks. You see, when we express root 2 in form of a by b, you have to prove 2 divides a and 2 divides b. In the first phase, the first equation, you have to prove using the fundamental theorem of arithmetic, 2 divides a and 2 divides b, the second. And in case of root 3, similarly, you have to prove 3 divides a in the first section, and in the second part, you have to prove 3 divides b. So 3 is a common factor of both a and b. So this is the trick you have to remember. But what you do, you just get it by heart, by memorization or by cramming, and even during exam or in the exam hall, you forget. And you don't mention the fundamental theorem of arithmetic. Basing on this, actually, the root 2 is proved as an irrational number. Hope you might have understood the fundamental concept, how to prove root 2 is irrational. Thank you for watching. Stay tuned to watch our next video. In our next class, in the next session, we shall discuss how zeros of polynomials are related to their coefficients.